So apparently I lied. I needed one more video on configurations before I could put this to bed. I need to show you the Noble Gas configuration, also sometimes known as the Noble Gas Abbreviation. And this is a shortcut for those particularly long configurations when you get down into elements like tungsten, gold, mercury that have 74, 80, 90, however many electrons. That gets to be a pretty long configuration. So you can use this abbreviation. Make sure you're reading the instructions on whatever worksheet or test or quiz that you're working on, because sometimes the instructions will say no shortcuts, in which case you cannot use this. Other times it will say write the Noble Gas Abbreviation for. So be sure to read the directions on whatever packet you're working on. Excuse me. So I've gone ahead and written the electron configuration for sodium here. 1s1, 2s, or 2, I cannot talk apparently. 1s2, 2s2, 2p6, 3s1. I've also written the configuration for neon, a noble gas. 1s2, 2s2, 2p6. So I hope you have already noticed that to this point, these two configurations are identical. They are the same. So when I write my configuration for sodium, instead of writing it all the way from the beginning, I can say, by putting neon in brackets like that, that tells my reader that the electron configuration for sodium is just like neon up to that point. So on your periodic table, here's neon. So 1s1, 1s2, 2s2, 2p6. To this point, sodium and neon have the same configuration. Then you would just continue on to what's left. For sodium, all that's left is this 3s1. So we go ahead and put that in. And this is the Noble Gas Abbreviation for sodium. An easy way to figure out which noble gas you can use in this abbreviation, and they can only be noble gases. Nobody else gets to do this abbreviation. It has to be a noble gas that you use to abbreviate. Is you start on the element that you're talking about, and then we go backwards on our periodic table until we run into a noble gas, neon, in the case of sodium. So let's do another one. Let's look at perhaps the electron configuration. Let's do something a little more exciting. Let's do yttrium. Yttrium, I think I'm saying that right, yttrium, anyway. 39 electrons to place. So not too bad, but still a ways. Here is yttrium. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Maybe I picked one that was too interesting. 5s2, 4d. Phew, there we go. Alright, so noble gas configuration. I put my finger on yttrium and I run my finger backwards until I run into a noble gas. So in this case, that would be krypton. So if we think about the configuration for krypton, pardon me while I write this, 3d10, 4p6. Oh, that's it. So, yttrium and krypton have the same electron configuration to that point. So if I wanted to write the noble gas configuration for yttrium, I would write krypton in brackets and then fill in the last little bit of the config. Whoop. That got me all the way to yttrium. So again, here is yttrium. Run my finger back, there's krypton. So I'm telling my reader that krypton and yttrium have the same electron configuration to this point. So ending with 4p6, all that precedes it is the same for the two elements. Then by including the next bit of the config, 5s2, 4d1, that's how you know that this electron configuration pertains to yttrium and not krypton. So again, this is called the Noble Gas Abbreviation, or the Noble Gas Configuration. Let's do one more, and we'll jump straight to the Noble Gas Configuration this time. Let's do something scary. uranium. Uranium's really scary if you have to write the entire config because it has 92 electrons. That is a heck of a lot of electrons. So it's down here on our second F level. So let's follow our periodic table up, 7th row, back around. Here's my noble gas that I'm going to use to abbreviate my uranium configuration. So I put radon in brackets, so that tells my reader that to that point, uranium and radon have the same configuration. Then from here, we continue on. 7s2. Here's 6d1. On down here to 5f3. 5f3. I'm going to do one more example. Let's do gold. AU. Gold. There he is. Let's run backwards, backwards, backwards. Xenon. That's my abbreviation. Xenon. And then we proceed forward. 6s2. Here's 5d1. Downwards we go to 4f all the way across is 4f14. Then back up to the d's. So as soon as you run out of real estate on the f's here, we go back up our black line to the d's. 1, 2, 3, 4, 5, 6, 7, 8 more in the d's. Here. I chose poorly in my example. So notice, these two guys are the same. So let's rewrite this slightly. I didn't mean to pick one this complicated, but that's okay. So 5d1 plus 8 is 9, 4f14. And if you remember from our last video, we said that anything with d9 in it is so close to that full orbital that the atom just can't stand it. He has to rearrange his electrons. So we promote 1 from the S into the D. Wow, I didn't realize I picked an example that required that much doings. So two things I need to mention on this gold. First off, the fact that anytime you do the 5d1 with lanthanum or actinium, anyway, then go all the way through the F's and return to the D's, you can in fact combine those D's into one level. It makes it a lot nicer and neater to deal with, and then you don't have to draw the d orbital twice if you're doing the spin diagram, the orbital diagram. This one, when I combined them, just happened to also be one of those orbitals, or one of those scenarios where the orbital moves to that full configuration. So, quite the example there. But that covers, I believe, everything I wanted to talk about with configurations, so I hope that refreshes your memory on this, or perhaps makes it clearer to you if you have not done this before. Happy configging!